All right, so optimization problems. A manufacturer wants to design an open box having a square base and a surface area of 108 meters squared. What dimensions will produce a box with maximum volume? Okay, so again, I will draw my box. Okay, open box. So I have here X and X, since they're telling you that it's a square base, and the height will be Y. So what's given to us? So it's given that the surface area is 108. So area is 108 meters squared. So what's the area of this box? So it's area of base, which is x2 plus the area of each face, which is xy, and there's 4 of them, so 4xy. Okay, and this has to equal to 108. Good? No questions so far? So of course I'm going to try to isolate the y, which is easy to do. So 4xy will be 108 minus x2, and therefore y will be 108 minus x2 divided by 4x. Okay, any questions so far? Okay, and now we want to maximize the volume. So we want to maximize the volume, which is what? Volume of a box is the area of the base times the height. So basically x2 times y. This is the area of that is the volume of the box. Okay, and I will try to express it everything in terms of x, which is easy, by replacing the y by what we found here. x2 times, and for y I will put 108 minus x2 over 4x. Okay, let's simplify this. So what do I get? 108 minus 4, I think, is 27. Divided by 4, sorry, is 27. Yeah, so 27x minus, and here I have x cubed over 4. This is the formula for my volume. Did you get this? Yes? Okay, good. So now I need to maximize this function on what interval? So what are the values of x?
0.
Sorry?
It could be 0.
It could be 0. Well, not exactly, because, right, if I divide by 0, then the y will be infinite. But you're right, it would be 0, not including 0. Okay, so x is from 0 until what?
10.39.
How much?
10.39.
So how did you get that?
I replace y by 0.
Exactly. So you replace y by 0 in here, and you'll get x2 equals 108. So 10.39, perfect. Or the square root of 108. This is the maximum possible value of x. Question? Okay, good. So now I need just to maximize this function with on this interval. So let's go. V prime of x is the derivative of this. 27 minus 3x2 over 4 has to be equal to 0. And so that means if you solve this, you get 27 equals 3x2 over 4. Divide by 3 times by 4, you get x2 equals 36. And so, oops, I have to move up. And so I get x has to equal to plus or minus 6, but of course, x can only be positive, it can be at least 0, so x is 6. Any questions? Okay, and if x is 6, what is y? So I will replace the x by 36 into here right away. I'll take my calculator. So 108 minus 6 squared, which is 36, and then divided by 4 times 6, which is 24, so I get 3. Okay, so I get y is 3. Okay, now what? You remember what to do? So we have to decide if when x is 6, is v at a maximum or a minimum? Okay, so I will find the second derivative. So v prime prime of x is equal to the derivative of this, which is negative 9x over 4. And then v prime prime at 6 gives me what? Gives me 327 over 2. So negative 27 over 2, which is definitely negative. And so I have a maximum.
Why do you do v prime prime?
Why do I do v prime prime?
Yeah.
Because we said last class that the second derivative is an indication whether my function is open downwards or open upwards. Okay, in terms of concavity. Okay, so if it's open downwards, did we do this together?
I don't remember doing
Oh,
it.
we never do this together.
We didn't do it. We didn't do it.
Oh, so I think we did it with the other class. I'm sorry. Okay. So I'm going to tell you this, what I just did here in a second. Okay. So I have a maximum at x equals 6. Okay. So what did I just do here? Okay. So what happened here? Okay. So this is called the second derivative test. So I'm going to write it here. I'm going to explain you what I did here. Okay, so if a function is, if f prime prime of x is positive, this means that my curve is like this. Okay, and if f prime prime of x is negative, that means that my curve is concave down. Okay, so positive, happy, negative, sad. Okay, that way you don't forget. And so in this case, if it's positive, that means that of course I have a minimum. Okay, but if it's negative, that means that here I have a maximum. Okay, you understand? So that's what I did here. Okay, so let me just put it like this so that when you look at the notes after, it's not like lost. Okay, so what did I do here? I found the second derivative and I plugged in 6. See what happens at 6. Is the function at 6 open upwards or is it open downwards? And I notice that it's negative, so it's open downwards. And so that's why there is a maximum here. Is this okay? Does anybody want me to repeat this?
How do we know when to use this?
How do we know when to use this?
Yeah, like when to check if it's positive or negative.
Well, you
in
could
the other
also
problem, it was
You could always check it.
okay.
Okay. Okay, so this is called a second derivative test. And we're going to do this much deeper soon when we do curve sketching, and we're going to have to determine when is a function concave up and when is it concave down. Okay, you will see. Okay, so concave down, like this, open downwards, means that I have a maximum. And so that's why I have a maximum at 6. And therefore, the dimensions of the box okay, that maximizes the volume will be, so I'm going to draw the box again here. It's a bit small. Okay, so it will be, of course, 6 meters by 6 meters. Good, my base is square, and this is 3 meters. There you go. So hopefully, if we didn't make any mistakes, if you find the total area of this box, it should be 108 meters squared, and the volume will be 3 times 36, which is 108 as well. Okay, well, whatever.
But sir?
Yeah.
Why don't we need to check it with the two values, like 0 and square root of 108?
You could do it. You should do it. You're going to see that you get 0. Okay, so we should do it. Let me do it here. So volume at 0 equals what? Volume at 6 equals what? And volume at square root of 108 equals what? Right, what you're saying?
Yeah.
So of course, at 0, this doesn't work, okay? Because, well, actually, it's going to be 0. Sorry. At 0, sorry. What am I doing? At 0, the volume, what's the volume is right here. This is the volume. Okay, so if you plug in 0, you're going to get 0. And if you plug in 100, square root of 108 here, you should get as well, you'll see that you also get 0. Okay, and if you plug in 6, let's try 6. So 6 cubed is 216, I think. 216 divided by 4, negative, and then plus or minus, plus 6 times 27, I get 108, just like as expected. So I get 108 meters cubed. And so this is my maximum, just like we found on exercise 6, just like we found with our second derivative test.
Sure.
Yep.
Does that mean we can do either or?
Yep.
Okay, thank you.
Isn't
Sure, I
the
have a
second
question.
derivative, sorry, isn't the second derivative 3 over 2? Because you just did, you're supposed to do 3 over 4 times 2, no?
3 over 4, sorry.
To get the second derivative, you just do 3 over 4 times 2, because you bring the exponent, and that gives you 3 over 2, not 9 over 4.
3 over 4.
You're supposed to just multiply it by the exponent 2, no? To get the second
I
derivative.
made a mistake here. Sorry, you're right. This is the second derivative is negative 6 over 4. Sorry, that's what you're saying?
Yeah.
Yeah. Sorry.
Just because I was confused.
Yeah, 6 over 4. You're right. So 6 over 4 doesn't change anything. So that's 36 over 4. So it's negative 9. Sorry, you're right. Doesn't matter because what's important for me is that it's negative. Okay, so second derivative is negative 9. Okay, we're going to talk. I'm going to talk to you about what does this negative number, the negative 9 mean. Okay, when we get to curve sketching. Any questions on this? Okay, so let's do the second one. Okay, so I will post this in the notes as well today. Second one. Did you do it? Did you start it? No, you didn't start it yet? So you want a few minutes to try it, or well, it's just that we have about 25 minutes to class, so maybe I should do it. Okay?
Yeah.
Okay, I'll do it. So what happens here is I have a wire that's 100 centimeter long. Okay, so 100 centimeters. And what happens is that I want to cut it, and with one part I want to form a circle, and with another part I want to form a square. Okay, so let's say I'm going to take here x. And of course, 100 minus x. And with this x here, I'm going to form a square. I think I'm better off to do the circle with x. It doesn't matter. It doesn't change anything, but just for calculations. Okay, I will do it. I will do the circle with x and the square with 100 minus x. Okay, so here I'm going to bend the x centimeters into a circle, and I'm going to fold the 100 minus x centimeters into a square here. Okay, and they're asking you find the length of each piece. So where do I cut it? So that the area, the sum of the areas, the area here and the area here, if you add them, is at the smallest. Okay. Okay, so what are the dimensions here? Let's go right away. So the circumference here is x, and the perimeter here is 100 minus x. So if the perimeter is 100 minus x, means each side is 100 minus x, right, over 4. That's clear.
What if we choose, like, for the x, we choose the square, and for the
It
100?
doesn't matter. It doesn't matter. It would work, okay? And here, the circumference is x. So it means that 2 times pi times the radius equals to x. And so the radius is going to be what? X over 2 pi. Is this okay? Okay, so now I need to minimize. So we want to minimize the total area. Okay, so what is the total area here? So the area of the disk, so the total area is the area of the disk, which is pi times the radius x over 2 pi squared, plus the area of the square, which is side squared. So 100 minus x over 4 squared.
How did you get that as the areas?
How did I get? I'm sorry, this is the areas?
Yeah, for the circle, how did you get that?
Because the area of a circle or a disk, right, it's pi r squared. Do you understand how we got the radius?
Yeah,
Okay, so what's the area of a disk? It's pi times the radius squared.
The circumference is x. So not the area is not x, the circumference is x.
I know. The circumference is x, yes, I know. So the circumference, x, equals to 2 pi radius, right?
Yeah.
So if you isolate r, if you isolate the radius, you get x over 2 pi. Good. And now the area of this disk is going to be pi times the radius squared.
Oh, okay.
That's the radius. Does this answer your question? Alexandra, you had a question?
why is it pi radius squared? Oh, that's the area of a circle. Okay.
Yeah. Okay. 100%?
Yeah, but why did you isolate the radius? Like, how did you know to isolate the radius at the beginning?
Because I need to be able to express the total area as a function of x only. You understand? I need to have an expression for the total area as a function to where do I cut my wire.
Okay, so you only need to have x's in your area. Okay.
Like every optimization problem we're going to do in this course.
Okay.
If you do calculus 3, you'll see there's more, but here there's only one. Okay. So far so good.
Yeah, thank you.
Okay, anybody else?
Sir,
Yeah.
I'm sorry, but I don't understand why the both are squared. Can you just repeat it?
Why this is squared?
Yeah, and the other one too.
The other one? Okay. So this is from, so I'm gonna write it here. Here. So the area is pi times the radius squared. That's the area of a disk. And the area of a squared is side squared. Right? You with me or no?
Yeah, yeah.
Okay. So what's my radius? It's this. So I have to plug this into R. Here it is. Yeah, yeah. Are you with me or no?
Yeah, sorry.
Okay. And then
Sir,
what? Sorry?
I have a question, sir.
1 second. I want to make sure that you understood. Alexander, you
Okay.
understand everything? This?
Yeah.
Okay, good. Yeah. What's your question?
Why can't you just do 2 pi r plus 4x equals to 100 and then isolate
What is it? What is it? 2 pi r?
plus 4x equals to 100 and then you isolate for r. You can do that too, no?
2 pi r. 2 pi r x, you mean? 2 pi what?
2 pi r plus 4x.
2 pi
Equals to
r plus,
100.
where did you get 4x? Where's 4x from?
I just made the side x.
Which side? Here?
Yeah.
Okay, so you call this x, okay. So 2 pi, and you call this r. So 2 pi r plus 4x equals 100, okay. And then?
Yeah, why can't you do that?
You could,
Instead of-
then what?
I tried it like that though, and I kept getting 20, and I'm trying it this way now, and I keep getting 20 again for x. So I don't know. Maybe I'm doing something wrong.
Okay, one thing at a time. One thing, I have to explore every avenue. So one thing you told me, you said that I could call this r and this x and say 2 pi r plus 4x is equal to 100. Good. And I want to find r in terms of x, right? That's what you're saying?
Yeah.
Okay, and then you're going to do the r here, you're going to express it in terms of x, and you're going to have an equation with x. That's good also. It's going to work. It should work.
All right.
It should work.
Thank you.
Okay, Rebecca, what was your question?
It wasn't a question. I was just saying I tried it that way before when I made the side of the square x and for the circle the radius was r, and I kept getting 20 for x, and now I'm trying it this way and I keep getting 20 for x again. So I don't know. Maybe I'm doing something wrong. I don't know. Just both, like, I don't know.
Okay, we'll see. We'll see. You get 24x, I don't know. Let's see. Maybe I'm going to get it wrong. I don't know. Maybe I made a mistake. It's possible also. Okay, so what's the area here? It's total area is this. So I'm going to simplify it a bit. So I get pi over 4 pi squared times x2 plus 1 over 16 times, and I'm going to open this up. So 100 squared is this minus 200x plus x2. Okay, just to make it simpler to derive after. Okay, let's simplify a bit further. So 1 over 4 pi times x2 plus 10,000 over 16 minus, so 200 x over 16 and plus x2 over 16. Okay, so this is my area, and I'm going to find now A prime. Okay, so A, you're with me?
I don't get how you how you simplified 100 minus x over 4 power 2.
So I pulled out of the over 4, I pulled it out squared, becomes over 16.
Mm-hmm.
And then the inside, I just did A2 minus 2AB plus B2.
Okay, thank you.
And so now I'm going to derive, and I'm going to get 2 times x over 4 pi, so 1 over 2 pi times x. This one is out because it's a number. and then minus 200 over 16, which is, if I divide by 4, I get, oh, the 200 over 16, could it be divided? I think it could. Not sure. No, actually, I don't think so. No, 12. So 25 over 2. 25 over 2x, and then plus here, if I divide, I get x over 8 if I derive. Sorry, there's no x here. Okay. Good. All right, so let's go now. Let's find when is a prime equal to 0. So x over 2 pi plus x over 8 is equal to 25 over 2. And then we solve for x.
We have no possible values for x.
Sorry?
We have no possible values for x.
No possible values? Why? Why is that?
No, because last exercise we put possible values for x.
Oh, yeah, you're right. Sorry, I forgot that. Okay, so x, what is the smallest possible value of x? It's 0, right? Go back here. So x, the smallest it could be at 0. So that means you use the whole 100 to build the square. Or x is 100, which means you take the whole wire to build a circle. Okay, so x is from 0 to 100. Thank you, I forgot that. You're right. Okay. So it seems fine. And I'm going to solve this now. So what do I get for x? So it's weird. I'm not getting the answer that I have here. So 25 over 2. Okay, could I do this right away? You guys okay with this? I could simplify this right away, or we want me to show you the steps here?
No, show the steps, please.
Yeah, for this, even though this is a grade 7 question. Okay, I'll do it. Okay, so it's x times 1 over 2 pi plus 1 over 8 equals 25 over 2. And so x will be 25 over 2 over, so 1 over 2 pi plus 1 over 8. Okay, so I'm going to calculate this value for x. So 2 times pi. So now I'm just going to use my calculator and calculate this here. Plus 1 over 8. X times 12.5. So I get 44. That's weird. Okay. Perfect. Well, so I guess 44. So I think the answer is right. Okay, and now I'm going to find, so I could either do the second derivative and plug in 44. Okay, so if you plug in the second derivative here, you'll see that it's positive. Okay, positive. The second derivative, you get 1 over 2 pi plus 1 over 8 is a positive number for any x. So it's for sure going to be a minimum. Okay, or you could just do the area at 0, the area at 44, and the area at 100. Okay, so at 0, this is out. So I have 100 over 4, which is 25 squared, is 625. centimeters squared. At 44, so 44 divided by 2 divided by pi squared times pi. Plus, and then 56 over 4 squared, 350. Okay, about 350.06 centimeters squared, and at 100, this one vanishes. So 50 over pi squared times pi, 795. Okay, so as you see, this is the minimum. Okay, so we got it right. It means that we need 44 centimeters for x, which means for the circle, and of course 100 minus 44, which is 56 for the square. And so 56 centimeter for square. Any questions? Question 3. So the Norman window, this is the classic question. So we have about not even 10 minutes left in the class. So should I do it right away? You guys okay with this? Yeah, I guess I'll do it. So a Norman window is what? Has the outline of a semicircle on top of a rectangle. Okay, so what's a Norman window? It looks like this. Okay, I'll just fix this straight. Okay, so this is a Norman window. No, it's going to be too fits. Okay, that's a Norman window. It's a rectangle, and on top of the rectangle, there's a semicircle. And what's given? There is 4 plus pi feet of wood trim available for all sides of the rectangle. So 1, 2, 3, 4 for the frame of this part of the window, and for the arc, the semicircle on top. Okay, so I'm going to call this, they want the dimension that will allow the most light through. So basically that will maximize the area of this shape. So I will call this radius x. So this of course is 2x, this is x, and this I'm going to call y. Questions? let's go for it. So what do we know? We are given that the total wood available is 8 plus pi. So basically x plus y plus 2x plus y plus the like length of this arc has to give me 8 plus pi. Okay, so we know that. So 2x plus 2x plus y plus the length of this is what? So 2
Pi x.
pi x, very good. So 2 pi x divided by 2, so pi x has to equal to 8 plus pi. This is given to us. Okay, in other words, 4x plus 2y plus pi x equals 8 plus pi. And as usual, I'm going to isolate the y. So y will be 8 plus pi minus pi x minus 4x, all this divided by 2. Okay? This is what we know. And now we want to maximize the area in here. So what's the area? Can you tell me what the area is?
Two xy.
2xy, perfect. This would be the rectangle. Plus
Pi x squared over 2.
pi x squared over 2, excellent. Okay, pi x squared being the whole disk, but half a disk, so over 2, perfect. Okay, what do we do now? Replace the y by what? By this, right? 2x times this big expression, 8 plus pi minus pi x minus 4x over 2 plus pi x2 over 2. Could do a bit of cleanup here, crossing out the 2's and distributing the x inside. So we'll have 8x plus pi x minus pi x2 minus 4x2 plus pi x2 over 2. This is my area that I wish to maximize. Okay, and so now I need to figure out what are the possible values for x and y. Okay, I mean for x, sorry. So what is the smallest possible value of x? Okay, so basically, if y is 0. Okay, so x is from, well, the lowest possible value of x is, of course, 0. Everything will be used for the y. And the highest value of x is if I plug in y equals to 0 here, I'm going to get 8 plus pi over 4 plus pi. Okay, so this you get by letting y equals to 0. Any questions? So now what do? A prime equals to 0. So let's find a prime of x. The derivative will be 8 plus pi minus 2 pi x minus 8x plus pi x. And this has to equal to 0. Okay, let's try. So this means that 8 plus pi, so minus 2 pi x plus pi x is minus pi x, minus 8x is equal to 0. So if I send this to the right, 8 plus pi equals to pi x plus 8x, so pi plus 8 times x, divide by pi plus x both sides, and so I get x equals to 1. Okay, and if x equals to 1, of course, it means that y is equal to, I replace x by 1 in here, and you will see that you'll get y equals to 2. Okay, almost done. So last thing we need now is to find the value of a at 1, well, at 0, at 1, and at this ugly value. Okay, or we could just find the second derivative. I prefer the second derivative here so that I don't have to plug this in. Okay. So let's do the second derivative test. So a prime prime is equal to, so the derivative of this is negative 2 pi minus 8 plus pi. Which is equal to negative pi minus 8, which is always negative. Right? It's always negative. And so you see that my function is like this. So it's definitely going to be a maximum. Okay, so a prime prime of 1 is definitely negative, and so we have a maximum at x equals 1. Good. And so my dimensions, my normal window will look like this. Sorry, moved. So y here is 2. Here I have 2x, which is 2, and that's it. That's the dimensions. So of course the radius here will be 1. And it matches with the answer that we have above.